So, since no one else is coming in, let's start. Good afternoon, everyone. Thank you for giving me your time. Today, we're going to talk about elastofoam, microcellular flexible PU, and integral skin, which is BASF's brand for these products. This slide has things I love. I love PU foam. I like to rest and I like to practice yoga. I can't do that position, but that's my target. This talk today is to introduce PU systems, talk about our commitment to sustainability, and going into the topic of PU flexible microcellular foam. To start talking about PU, we have to talk about what are rigid foams, flexible foams, and case applications. So, rigid and flexible foams, the difference is reticulation. So, functionality above 4 is rigid, below 4 is a flexible foam. And case is the non blown material. So, coatings, adhesives, sealants, rigids, and flexible depends on the size of the molecule, functionality, etc. But flexible foams, which is part of what we're going to talk today, integral skin and microcellular, falls under flexible foam. Our focus is to talk about foams for the automotive industry. In the automotive industry, we have applications on the sealing lining, foam on the steering wheel, the shift gear handle, headrest, seat, flexible foam, also in encapsulating cables, glass, the sealant for the filters, impact absorber, and other parts that are required, like the mud stopper that can be made with flexible foam. Sorry guys, the clicker here isn't working well. I think the clicker is afraid of the technician. Okay. This is to give you an idea. These are BASF units for PU systems. I would just like to point out that our unit in the city of Guaratinguetá uses 100% green energy. Each country will have their energy matrix. Each one has more or less green energy. And to talk about sustainability, BASF has sustainability targets, which is to reduce CO2 emissions by 25% by 2030 and achieve net zero CO2 emissions by 2050. It might seem a bit bold, but it is reachable. It's a target that we already achieved because since 1990 to 2018, BASF emissions reduced 50% while sales increased 50%. So it's not something unachievable. And I'll show you examples of how we can make PU that has less CO2 emissions. I'm going to talk about some examples of sustainability and how to use and recycle PU. I'm really having trouble with the clicker. One of the ways is producing using green energy, biomass. That's one of the ways of making the material be more sustainable. But PU itself and its use is already sustainable. We have many tools to calculate the amount of CO2 and energy in a process from production to use, and we know that to generate 1 kilogram of PU, we spend 3 kilos of CO2. It might seem a lot, but actually, this foam, as in this example for thermal insulation, will save energy, and at the end of the shelf life, it would have saved 350 kilos of equivalent CO2. So the use of PU is also sustainable. And recycling. We already have examples of practices, which is to recycle the produced PU and turn it into polyol again to use it to produce other parts. And none of the examples that I'm going to show you of elastofoam have this possibility. Let's just set apart two things. What is microcellular PU and microskin? Microcellular PU is a material that looks like integral skin, but the skin isn't necessarily integral. It's a high density flexible foam that forms a wall, but the wall isn't thick. In the formula, we don't have any blowy agents to create that skin. Now we have non-emission materials to the cabin to prevent forming chemicals in the atmosphere inside the car. So, and you might have some health issues. We also have a tool that simulates how the foam will form inside the mold. We can see experimentally how the foam is going to flow inside the mold, and we can identify critical issues, our air vents, and the leftover materials, which are these. This is the leftover material. We have about 5 to 10% of the steering wheel material, and BASF gets this back from our customer. We treat it, make it turn into polyol again, and the customer can use it again in their formulation. Unlike microcellular, the integral skin has a skin. You can see it here. It's very visible here and here. Inside we have a blowing agent, which is liquid at room temperature. When the reaction takes place, it changes state, it becomes a gas, and inside the mold, it will condense on the sides of the mold. That's why it creates the skin. This system can make parts uh, that are very large. We conducted this work to size each characteristic that affect the size of the end part. We can control the size of the part without having any dimension issues. All these projects switch the blowing agents to those who have a lower carbon equivalent. Just to show how PU is sustainable, we are reducing the amount of equivalent emissions for these two projects from 20 tons per year, which equals planting trees in the expanded downtown area in Sao Paulo. It would be great if we only had trees in that area. This is what I had to show you. Okay, great. That's what I had to show. This was my talk for today, and I'm here open to answer questions. This is my one of my favorite topics. Please feel free to ask questions, and if you do have a wish, let me know. André, thank you very much. He will be at the BASF booth, and if you do need further information, thank you for your presence. Thank you. Now we will have PureCom's presentation. The topic is the impact of PU in decarbonizing the automotive industry. It our speaker is Audrey Silva, the R&D manager of PureCom Chemical and awarded with the Award of Excellence last night.